Hello student, welcome to Vidyanest. Today we are going to start a new chapter, that is probability. This probability is called black portion of mathematics because generally from the gambling the probability is inherited, the concept of probability. Okay, is the chance factor. So this probability has strong, what I can say, impact in economy of a country once upon a time. Now we are going to start probability. Conceptually, we get stuck in solving probability in board and joint because we have lack of confidence in theoretical part. Okay, generally we are learning formula, but knowing formulas is not the path to reach the final conclusion in probabilities problem. So let us discuss about the basic concept of probability. Probability from junior class you are being taught. What was the definition you got in probability? See, probability of occurrence any event is what? Favorable event by total event. Favorable event by total event. Favorable event means, total event means sample space. I hope you are taught set theory. Sample space. X universal set NS, that is total event, cardinal number, this is called total number of elements in S. And favorable event means number of elements which is involved in favorable set. Okay, NE by NS, that is PE. Okay, this probability, always the basic of probability, it lies between 0 and 1. Okay, once you get probability of any event is 1, that means it is called certain event, means which occurs once, certain event. Suppose if you get probability of null, that means cardinal number in null set 0, that means that is 0. So probability cannot cross 1, cannot come below lesser than 0. So it always lies between 0 and 1. Okay. Now in set theory we are taught what? Suppose this is universal set. Universal set. And suppose there is an element X. This is A. There is one element X. The figure depicts what? Does this element belong to A? No. X does not belong to A. So what does it belong? A complement. A complement. That means A intersection A complement always null. Therefore, cardinal number of n A intersection A complement n null is equal to 0. So, probability of this part is zero always. Okay. Now, this thing, if A intersection B is null, then these two event is called mutually exclusive events. Mutually exclusive events. And if A union B is equal to S, means universal set, then A and B are called mutually exhaustive events. Exhaustive events. Okay? Mutually exclusive and exhaustive. Now, this part we are taught. Now, you see in class 11, you are taught N A union B in set theory. Na plus Nb minus Na intersection B. Okay? Na intersection B. Now, if you divide both side by Ns, if you divide both side by Ns, then that will give you one important result of probability, that is P A union B, favorable by total, this by this, PA, this by this, PB, this by this, PA intersection B. And in set theory, you had got the concept, union means OR. A and B. Okay. So this concept you got early. Now, what happens in case of P A union A complement? It can be compared to P A union B, which we have just discussed. P A plus P A complement minus P A intersection A complement. Now, you just observe that P A intersection A complement just derived 0. Therefore, P A P A complement, this part will no longer. What about P A union A complement? A union A complement is A complement. It gives you total universal set A. This is called partition in set theory. Partition. PA, probability of certain event. PA plus PA complement. What about PS? 1. PA plus PA complement. So from here we can conclude one property PA complement 1 minus PA. One of the most important property. PA complement is 1 minus PA. Now, example, suppose probability of getting a job is 2/3. What is the probability of not getting a job? Means its complement. Probability of not getting a job. That means job, its complement. In some book, complement is denoted by this superscript C or by bar or by dash. Understand? Matter same. Matter is same. That is 1 minus 2/3, 1/3. Okay. Hope you have got the concept of the finding the probability of complement. Now the matter is most important matter pursues from here conditional probability. Conditional probability. What is conditional probability? Suppose I'm giving, a cricket match is being played. Now the event win or loss depends on the occurrence of the match. Okay, if a match takes place, then it will be decided that whether a team wins or loss. So win or loss depends upon the match. Suppose, another example, suppose you are sitting for exam. Result will be out and you will get good rank in joint entrance. But the rank depends upon what? Depends upon the exam. If exam takes place, then the question of getting good rank in joint entrance occurs. So this event, later event, depends on the event which is already occurred. Understand? Okay. For example, in a cricket match, the match first has to be played. Then the event win will come. The chance of getting a winning team or losing team will be discussed. What is meant by that? Then what concept will knock at our door? See, two events partially overlapping with each other. That is match and that is win. Okay? That is match and win. See, this region depicts what? The winner of the game who had take part in this match. Yes or no? That is both. This part is both. it depicts the condition of both occurrence of both the event. So in intersection match intersection win by total event. Total event means universal set. It means, well, you can ask me what is universal set. At the same moment, so many matches are being played on. Not only that match. Okay, that is universal set. By so that gives us what? This part gives us the probability. Probability of match intersection win by probability of occurrence of the match. Okay, so this is the favorable event, this is the total event. Okay, then I can say it is conditional probability. The condition of choosing winning or losing team depends upon the occurrence of match. So it is an example. Probability must be understood by some daily life example. So if I generalize it, see A stroke B. This is called A stroke B. A depends on B. So keeping parity with that example, the generalization states as what? P A intersection B by PB. P A intersection B by PB. Here, the event A depends on B. So B has already occurred on and A depending on that. Here B has already occurs and A is occurrence depends on B. Okay, A's occurrence depends on B. You can expect result, but result depends on examination. Had examination not been there, we would have not got any result related to that examination. Understand? So that is called conditional probability. Now, we have just got P A stroke B by PB. So, P A stroke B will be into PB. P A stroke B will be P, just cross multiply. P A intersection B will be PH stroke B into PB. Now, I am exchanging A and B with each other. Means in place of A, I am placing B. In place of B, I am putting A. So here also, A and B will be exchanged with each other. So B intersection A into PA. But this result and that result are same. A intersection B and B intersection A are same. In set theory or algebra, it is called commutative property. Commutative property. So these are same. That means these two must be same. P A stroke B into PB, PB stroke A into PA. So from here, one important result I can bring. What is that? B stroke A, P A stroke B into PB by PA. So that is one of the most important property. It will have strong uh, you know uh, relation to Bayes theorem. See, that part is a little bit clumsy. See, P A stroke B into PB by A. So this result which I have just rubbed. Okay. PB stroke A means A stroke B into PB by PA. So that is one of the most important property of conditional probability. Now, in conditional probability, another condition to be used. What is that? Probability of no occurrence of not A and not B. It can be placed in this way. Neither A nor B. So how to write it in mathematical form? See, P A complement intersection B complement. P A complement intersection B complement. What I will do with this? With this, what should I do? How to proceed next? See, due to inadequate place, I am writing here. In class 11, in set theory, we are taught one important property. What is that? A union B whole complement. De Morgan's law. A complement intersection B complement. So you recall your memory and drag that concept here. What is that? I can write, instead of A complement intersection B complement, I can write A union B whole complement. Then from here, how can I proceed next? Today we have got this concept. You see, PA complement is 1 minus PA. Use that. 1 minus PA union B, and PA union B is what? 1 minus PA plus PB minus PA intersection B. So this is the way you can define the problem if you get the the required event as neither A nor B. Understand? Hope up to this stage you have no doubt. Now, see, two sets are overlapping partially. This is A and this is B. We have just got A stroke B is equal to probability of A intersection B by PB. Okay. So that was the favorable event and this is the total event. Okay. Now sometimes exception can take place. What exception? Suppose, see, if I take the example of two sets partially overlapping, result, and this is exam. What is depending on what? Result is depending on exam. So, here condition comes. Result depending on exam. So, we have just got the concept that first in numerator we get the condition that both the events occur, and denominator the favorable total event, because exams or examinees are the total event, out of which few will be successful candidate who are going to get result. But the question is, this is the favorable event. You can ask me, the person who is staying here means this area indicates what region? The students who is sitting for the exam are getting this result. But sometimes it happens, the students are getting result without giving exam. Without giving exam means, suppose you are giving JEE exam, and you will get, if you get chance, you will be belong to this region. But at the same time, some students are giving CA exam. Suppose there is a student is giving CA exam. That means his or her result does not depend on the same exam. Understand? Means this exam will occur or not. This exam will occur or not. That guy will get this result. That means his result is independent of that exam. Understand? Suppose you are taking part in a cricket match and you want to win. That is the match. And suppose you are belonging to this region, not this region. That means you are not belonging to the region which denotes the favorable part. Suppose this region. What is meant by that? Win. Without playing the match? No. Suppose, due to cats and dog rain, the match is abandoned. Okay? So by toss, one team is announced as winner. That means the team somehow has won the match, but without playing the match. That means their winning did not depend on the match. So that type of event are called independent event. I have told you that to understand probability or get good grip in probability, some silly examples help you need to take. So here, this person, suppose if exam is not taken, but all are invited to take admission in a college for some course. Okay, sometimes it happens few courses are not that much of lucrative. That department is suffering from students crunch. Then they are announcing that, okay, you take admission in this course, no exam will be required. So in that case, the result or success does not depend on exam. Means exam will occur or not, he will get result. Okay. So in this case, the event result is independent of the event exam. Or in this case, suppose without playing the match event, if one team is selected as winner by tossing or some other rule, okay, that means match will occur or not, the team will win somehow. In this case, or see another good example, suppose two teams are to take in a cricket match. So if one team is absent, then automatically another team will be announced as winner. That means it is a better example. That means the winner team, match will play or not, because opposition is not there. That team will be announced as winner. In this case, winning the match and this match are independent to each other. Win and match are independent. Okay. So, considering these two examples, that thing has become an easy task for us to get good grip on conditional probability, because here students are fumbling. Why? To understand what is independent and what is dependent. Generally, if a match is being played, then winner or loser will be decided on the occurrence of playing the match. Okay, but in some cases, this thing occurs. Opposition is absent in the ground, so one team is selected as winner. If I take the reference of 1996 World Cup, Australia was absent in a match and Sri Lanka was announced as winner. So in that match, the winning team did not depend on the match played on. Understand? So that is an example. Now we can generalize. We can generalize this. You see, P A stroke B. If you get P A stroke B is equal to PA, that means A does not depend on B. A does not depend on B. That is, A and B are independent of each other. Independent of each other. Okay? Independent of each other. Independent of each other. So, what changes will come in that conditional probabilities formula if A and B are independent of each other? Let's see. We got this result that P A intersection B is equal to P A stroke B into PB. Now, if A and B are independent of each other, if A and B are independent of each other, then what can I write? P A stroke B is equal to PA. So you plug this value. Instead of PA intersection B, you can put here. Therefore, PA intersection B is equal to PA into PB. That is the condition of independency. Condition of independency of two events A and B. Condition of independency of two events A and B. Okay.